So in this video, we're going to be reviewing exponent rules like you did in Math 101. So these exponent rules will apply to the rational exponents for this class. However, I'm going to review the rules with just whole numbers like you did in Math 101 in case you have forgotten. So you have several exponent rules. The name, I'm not so much worried about that you know the name. What I want you to know is the actual rule. So power to power rule says that you have a power to a power. So I have two little exponents next to each other and you multiply. So an example of that would be x to the third squared. You would do 3 times 2, which would give you to the 6th power. Product rule says that if you have two big bases being multiplied, that you add them. So the thing with product rule is that the bases have to be the same. So if your bases are the same, then you can add the exponents. So an example would be x to the 5 times x to the second. You would have x to the 5 plus 2, x to the 7th. So notice the difference between power rule and product rule. Power rule says that you have two little exponents, you multiply. Product rule says you have two bases, two exponents. So make sure you keep those two straight. A little mnemonic device that I often teach is this thing called PIMA, so P-M-A, and the P stands for power to power, so power to power you multiply, that's what the M stands for. If they're being multiplied, PIMA says that you add them. So if you can remember PIMA, P-M-A, P stands for power to power, so the thing below it tells you that you multiply. The M stands for multiplying, so if you have two bases being multiplied, the A tells you to add them. Okay, so the next one is quotient rule. So quotient rule, you have x to the A over x to the B. Again, the bases have to be the same. So unless the bases are the same, you can't do this. But if the bases are the same and they're being divided, you are going to subtract top minus bottom. And then it goes on top. So notice this exponent, it then went to the top. Technically that is x to the A minus B over 1. However, I don't need to write the minus 1. So an example of this would be x5 over x2. Because they're being divided, you would subtract top from bottom, which would give you x to the third. The reason is because on top, that said I had 5 x's lined up. On the bottom I had 2 x's, so 2 of those x's are going to cancel, which leave me 3 on the top. You can remember this because the division bar looks like a giant subtraction sign. So that's how you can remember that the quotient rule you subtract. Power of a product, again, I don't necessarily need you to know the words, says that if you have two things to a power, you can quote unquote distribute. It's not really the distributive property, but says that you can give each power inside its own exponent. So you have x to the A, y to the A. Now for power of a product, it doesn't matter that they're the same. You're just going to, again, we usually lose that term, distribute each thing inside to its own exponent. So an example of this would be 4x squared. You're going to give the 4 squared and the x squared and get 4 squared x squared, and then simplify and have 16x squared. Power of a quotient is the same thing, only instead of them being multiplied, they're being divided. So you still do that distributive property, but it's not really. You give the top a squared and the bottom a squared. So an example of that would be 1 over 4x squared. I'm going to square the top, square the bottom. Now on the bottom, I have two things being squared. So now I'm actually going to apply the power of product. So I have 4 squared x squared, which will give me 1 over 16x squared. So just an example of that. Negative exponent says that if you have a negative exponent, let's use x to the negative b, the way that you can make the negative exponent positive is move it to the opposite floor. So if it was on top, move it to the bottom. If it was on the bottom, move it to the top. So here, this one's on top, so I'm going to bring it down to the bottom and change the sign. If it's on the bottom, so if I have a negative exponent on the bottom, the way to make it positive is to bring it up top, change the sign. So the little mnemonic device I use is cross the line, change the sign. That's how you can remember what to do with these. Cross the line, so bring it from bottom to top or top to bottom, and then change the sign only of the exponent. So an example of this would be 3 to the negative 5. Well, that's the same thing as 1 over 3 to the 5, because I took it to the bottom and I changed the sign of the exponent. The last two are nice and easy. The zero exponent says that anything to the 0 power is 1. It doesn't matter what is inside to the 0 power. So an example, if you have this, because that whole thing is in parentheses raised to the 0 power, it's all going to equal 1. X to the 0 equals 1. Y to the 0 equals 1. Anything to the 0 power is 1, not 0. It's 1. Last one says that if you don't see an exponent written, that you can write a 1 there. So that just says x to the 1 power is x. So an example would be 4. Well, if I wanted to write 4 as an exponent, I would put a 1 there. Now this you may see, you'll just see numbers or x's or y's standing alone. Just know that the 1 exponent says that if you don't see an exponent, it's an implied 1.